Okay, this is one of the problems we were looking at today about discontinuity and vertical asymptotes. Okay, and we started factoring, and then I didn't really know for sure how to tell you how to go from there. Okay, but this is the idea. Okay, whenever you have a function and the denominator is 0, okay, that means one of two things. There's a removable point of discontinuity, or there's a vertical asymptote. Okay, there's a removable point of discontinuity if you have the same factor on the top and the bottom canceling out, and you have a vertical asymptote if there's not a canceling out of anything, like if you're left with 0 in the denominator and that factor does not go away. Okay, let's look at that problem in more detail. I'll try to explain better. Okay, so we were factoring this out perfectly well. You still want to factor. Whoops. Okay, when you factor out the top, you can factor out an x squared. And when you factor out an x squared, you are left with 3x plus 2. Okay, when you factor out the bottom, okay, the only thing you can do is factor out a common x. And when you do that, you're left with x minus 1. Okay, so this is our problem factored out. And right away, okay, we know that at x equals 0, and where x minus 1 equals 0, which would be x equals 1, okay, at these two places, at x equals 0 and x equals 1, there's something going on. Okay, it's either a removable discontinuity or it's a vertical asymptote. Okay, so let's just look at each of these. Okay, this x, okay, notice how this x actually cancels out. Okay, so since that x cancels out, that means at x equals 0, there is a removable discontinuity. Okay, there's a removable discontinuity there because it canceled out. Okay, but this other place where x minus 1 equals 0, or in other words, where x equals 1, okay, that's not canceling out. See, there's not an x minus 1 on the top. So x equals 1 is a vertical asymptote. Okay? So if you have 0 in the denominator, it's going to be 1 or the other. Okay? But if the factor actually cancels out, it's going to be a removable discontinuity like it was with x equals 0. If the factor doesn't cancel out, like x minus 1, okay, that place is going to be a vertical asymptote. And I have a picture of the graph from Desmos. Okay, here's a graph of it. I did have to put in the point of discontinuity, the removable discontinuity there at 0, 0, because Desmos just doesn't do that. Okay, but notice that there should be a point of discontinuity at x equals 0. And this right here is the line x equals 1. And at x equals 1, that is a vertical asymptote. Okay, Kip, I hope this helps. I'll give you more videos of some of the other problems too.